In this video, I'll be covering problem 7, all the problems with complex, with imaginary numbers from A to J. If you take a look at A, you've got a quantity squared minus a quantity squared. Please remember, if you have a quantity squared, you need to write it twice. And you can either use the box method or not use the box method. You can just double distribute. I'm going to use the box method. It helps some students, so that's what I'm going to do. So 2 times 2 is 4, minus 10i, minus 10i, positive 25i squared. The nice thing about this, using the box method, is that you always end up with like terms vertically. So these two terms, these two terms you should combine. So that would be a 4 minus 25, which gives you negative 21. And then negative 10i minus 10i is negative 20i. Not I squared, but I. Then I'm going to subtract whatever's in this blank that I get when I multiply 3 plus 4i times 3 plus 4i. So I'll set up the box again. Three times 3 is 9, 12i, 12i, 16i squared, where 16i squared is 16 times negative 1, which is negative 16. So I'm going to combine negative 16 with 9, which is negative 7, and then 12i and 12i add to make 24i. This is where you need to be really careful. You are subtracting this quantity here. When subtracting, remember you're essentially distributing a negative, or just remember changing the sign. So what I would do is change your minus to plus and change the sign in the quantity behind it. Then it's just a matter of combining your like terms. So I'm going to rewrite it just so it'll be a little cleaner. And this is plus 7 minus 24i. I no longer have to worry about this plus 1 deal because that was being multiplied. Keep in mind, I'm not adding 1, I'm just multiplying. So when I combine, make sure you combine. Uh-oh, I made a mistake here. Oh, I don't know why I wrote 1 here. It was negative 21. Sorry about that. That was negative 21. So when I combine negative 21 and I add 7, I get negative 14. And then negative 20i subtract 24i is negative 44i. And that would be my final answer for A. So negative 14 minus 44i. I'm going to write it on the sheet here. Negative 14 minus 44i. Notice I've got I not to any other power other than 1. If you have any answer in any of these problems with an exponent greater than 1, then you need to continue to reduce. Now for B, you've got a high exponent here. Please remember that you simply need to divide by 4. One thing I highly recommend you do when you get your test is write out your I chart, so that it'll help you. Please write out the full chart. I'm finding that when students do not write it out, they write something incorrectly. So I down to I squared, and remember I1, so I1, where the 2 in the middle, I squared and I cubed, are the ones that are negative. When you divide by 4, remember to look for either 0.25 at the end, 0.5, 0.75, or it divides evenly. So I always relate this to 25 cent, 50 cent, 75 cent, and a dollar. Well, if we take 311 and divide by 4, 311 divided by 4, we get 0.75. If it ends in 0.75, I have to use negative I. So that's my answer, negative I. Okay? Next, for C, I have a binomial times a binomial, so I'm going to double distribute. 6 times 2 is 12. 6 times negative 7 is negative 42 with I. 5i times 2 is positive 10i. And 5i times negative 7i is negative 35i squared. Remember that I squared from your chart, I squared is negative 1. You cannot get by in this class and not know that I squared is negative 1. You have to know that all the time. So this is negative 35 times negative 1, which is positive 35. When you combine the integers 12 and 35, you get 47. When you combine your I terms, negative 42 plus 10 is negative 32i. That's the final answer. Next, for part D, you're going to have to combine a couple of steps here. We've got the quantity 2 minus 7i squared. So I'm going to do this on paper here. 2 minus 7i times 2 minus 7i will give us 4 minus 14i minus 14i plus 49i squared. I squared is negative 1, so this term is going to turn into negative 49, which I combine with my integer 4. That gives me negative 45. If I combine the I terms, negative 14 minus 14 is negative 28i. So that is my numerator, which I then divide by 6i. Okay, so all I did so far was simplify the top, and we get negative 45 minus 28i. The 6i, I multiply by the conjugate. I can use negative 6i, or I can use negative I. I'm going to choose to use negative I, because if I do so, rather than use negative 6i, I won't have to reduce like I normally would. Keep in mind that when you are multiplying this together, this is really a 6 times negative 1, which is negative 6, times I squared. I squared is negative 1. Negative 6 times negative 1 is positive 6. So in my answer, my denominator is positive 6. When I distribute negative I to my numerator, I get negative 45 times negative 1i. Negative 45 times negative 1 is positive 45i. Then negative 28i times negative 1i is positive 28i squared. You've got to further simplify and recognize that this is 28 times negative 1, or negative 28, plus 45i all over 6. If they have a common factor, you do need to reduce. But 28 is 2 times 14 and 7 times 4, so they don't have any common factors. So your final answer would be negative 28 plus 45i over 6. All right, next for E, we've got negative 7 over 2 plus 5i. Wait, for what? Sorry, guys. Writing a note. Bye.
Hey, classes.
So I'm going to multiply by my conjugate, which is 2 minus 5i. Please remember the conjugate. The only thing that changes is the operation. Only the operation. When you distribute up top, you get negative 14 plus 35i. And on the bottom, we're going to end up with 4 minus 25i squared. Notice I'm not using the box method or double distributing because the whole point of using the conjugate is that the middle terms with I in them will cancel out. So now I have 4 minus 25 times negative 1, which turns into 4 plus 25, which is 29. So my final answer will be negative 14 plus 35i all over 29. For F, first thing we should recognize is we have square root of a negative, so we should put I out front and make that positive. When we break this down, we get 5 times 100. And actually, once we know that that's 100, we should know that that's 10i square roots of 5. We just have to then take care of your variables. So you have 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, and a g. You're looking for pairs of factors. You have 2 pairs of e's and 1, 2, 3 pairs of f's. So that's going to give us 10 e squared f cubed I square root of fg. But pay attention, up here in the original problem, you have a negative. So we've taken care of everything except you can't forget about that negative. It's still there. So this would be your final answer. All right. Next, for G, we've got a string of powers of I. We're going to need to refer to our I chart. I chart. Right here. And divide each of these powers. But what I recommend doing is putting blanks. Like, we got to simplify that, and then we subtract that one, and then we subtract whatever that one is, and then we subtract whatever that one is. So put some blanks, and I promise it will help you keep your sign straight. So when we do, I'm sorry, I'm going to focus it and make it a little clearer. Or not. So when we do 32 divided by 4, it divides evenly. So think about that as your whole dollar. So that equates to 1. 30 divided by 4 ends in 0.5, which equates to negative 1. 36 divided by 4 divides evenly. We equate that to a whole. And 46 divided by 4 ends in 0.5 again, so we equate that to negative 1. Please don't even make this hard. Just type in 1 minus negative 1 minus 1 minus negative 1. Exactly what we have on paper. And the answer is 2. All right, so next, 4i cubed, we can write it 3 times, but we should also know that we can simply find 4 cubed in our calculator. That is 64 I to the, and if we wrote out I cubed 3 times, we would have 9 i's total. So that's I to the 9th. That comes from multiplying exponents. Power to a power, you multiply exponents. So using our calculator again, we need to simplify that power of I. So 9 divided by 4 ends in 0.25. 0.25 is I. So this is 64 times I. Final answer, 64i. For J, this is simply a monomial times a binomial where we are multiplying. 3i times 5 is 15i. 3 times negative 8, negative 24i squared. negative 24 times negative 1, making this positive 24. So our final answer is 24 plus, because our I term is positive, so 24 plus 15I. And that concludes going over problem 7.